SE456 Space Invaders Final, Nicholas Regano. As you can see, we have our start screen here. We've got our scores, score text, all that. Tried to lay it out as close as possible to the actual thing, but that was kind of difficult to get the exact spacings. If we hit space, we can go into the game. You can see I can move left and right. We can toggle on the bounding boxes, and I'll just drive into a bumper here. You can see I can stop moving. I can still shoot on the bumper though. We'll shoot at these guys. There's the UFO, and its extremely annoying noise. We will try to clear some waves here. We can see that I can drill through the shield, which actually kind of a good strategy to take out some of these aliens. You can see the score is changing. When I hit an octopus, you'll see I'll get 10 points. When I hit the crab, I will get 20, and the squid, I will get 30 points. We can also shoot their missiles out of the air. I'll try to demo that. Oh, there we go, right there. I'm going to try not dying because I would like to make it to the second round since I have to complete 2 whole rounds. I'll try to get a UFO here in a little bit. You can hear they're speeding up, and the bombs are colliding with the shields as well, so that another key feature there. Try not to get trapped in the corner, see if we can get the UFO. And I am terrible at hitting that thing. Alright. So, due to the bomb generation, this guy's gonna drop a bunch. Oh, I think we just got the UFO. Sweet. Alright, there's the respawn there. Let's see if we can clear this wave. They should start a little faster. Marching. Okay. I'll just spam shoot here, see if we can take out a bunch. You can see they're speeding up again. Almost got me with that missile there. We won't squander our lives just yet. Try to get some of these guys over here. Let's get this guy over here. He's really screwing us. Man, I can't hit a thing. Alright. And now if we go, I'll just get hit by some bombs. We can see the ship death animation there. And we'll just hit another bomb. And we'll finally hit one more bomb. And we can see the game ends. Our high score gets put into the high score location. And if I hit space, we'll go back to the start screen again. And we'll start. Thankfully not getting hit by one of the bombs that drops right quickly. And that is pretty much everything there. I think I have to destroy a whole shield as well. So let's do that real quick. Without dying, hopefully. As you can see, there's a lot of little bricks in each shield. Alright, and then we'll just toggle the bounding box again to show that it's totally away. And there's another example of us hitting missile with the splats as well. Alright, let's delve into the code here. Alright, All right, let's get going. All right, so we'll start with the singleton pattern. Texture manager should be a singleton, so you can see it as a private constructor. We have to call create on it, and then it will just have an instance that's static, so it's available anywhere. It's only created once, so if it's null, aka when we first create it, it'll just do it. If we call create again, nothing will actually happen. Different, it'll already be created, so it'll kind of just do nothing. And this is the example of that. Fly weight, pretty simple. Our glyph manager is a fly weight, not a crazy amount to actually show here since um, we are not really using it as a flyweight since we load all the glyphs. We're preloading all the glyphs. So kind of defeats the purpose. The purpose of the flyweight is so we don't load it until we need it. But due to us having a time sensitive thing, such as a game, we don't want to just be calling new if we can help it in the middle of running. Our iterator, you can see pretty simple. We have a current first is done next method. We have a D-link and an S-link in this case. We'll just go into the D-link real quick. Here's the code. I'm not going to go too much into that. Strategy pattern. Our bombs use strategy pattern. So we create the bomb and then we assign it a false strategy, and that never changes after its initial assignment. So we can make any type of bomb. There's a dagger bomb, straight bomb, and a zigzag bomb. But we can give, for example, a dagger bomb a zigzag behavior, although that wouldn't make much sense in this case because it's perfectly mirrorable object. Factory pattern. We have an alien factory, not a super useful UML diagram here. So we'll just go in. We can see main meat and potatoes of this is that we give it an object name that we want to create and a position. It'll go through, it'll check if it's on the ghost manager, aka if we've already created it before and destroyed it, and this way we won't have to call new again. If it's not, it'll just come down here, create a new object, do all the setup, and then hand it back to the caller, which in this case is usually us. Proxy. So this is kind of just the UML extended version, basically just showing a little bit of use case. There's a manager for it. What we really want to focus on is that the proxy has only a handful of the fields as the main object. So when we go into the proxy and we update, we end up pushing to real, which basically means we set the real sprites value to whatever this is. The advantage of this is we don't have to carry around all of this other garbage, basically. When we're just trying to change the position of an object, we can just give the proxy and do it through there. So it's a lot lighter object to carry around. State pattern. Ship uses the state pattern for its move and missile. So the move state, for example, starts in the any state. We can move right, we can move left. If we go back in here and we say, oh, okay, the ship's hitting the right bumper, we switch the state. When we call move left, nothing happens. Actually, this would be the no left, so we'd be hitting the left bumper. My bad. But the idea is still the same. Hit the left bumper, we can only move right. As soon as we move right, we set the state back to both directions. Pretty understandable. Visitor is basically impossible to show easily. So we have this visitor abstract base class. It has all our visit methods. We'll try to go in and find one. There's 11 references to the missile group. This has got to have something. So we can see in here the missile group accepts other visitors, which in this case could be anything. Could be any other visitor. So say we have a bomb, for example, visiting. What will happen is the missile group would accept the bomb as the visitor. The bomb would be this other, and we'd call bomb visit missile group, for example. So that's how that works. Adapter pattern, pretty simple. We can give our example of our textures are an adapter for the Azul texture. We don't want to deal directly with the Azul texture. we don't really want people to think about the Azul textures. We just want people to think about our textures. So we go in here, we give them some convenience functions to kind of cover any use case we would need with the adapter or with the actual underlying texture. But this sort of just wraps around it and gives a nice interface, convenience, and allows us to control what actually happens with the real texture. The observers, once again, a little difficult to, I guess, show. We have these subjects, we have the actual observer type, which just has these notify listeners, notify all. So our collisions work on our observers. We make these collision pairs. When a pair is triggered, it notifies all the listeners that have been added to it, been attached to the pair. That'll go over here. That will call the observers and notify function. And if we go in and find an observer, we can see, let's just do the ship bumper. So the ship bumper, when it hits a bumper, the observer is notified. And we can see we come in here, we figure out which bumper we hit, and we set the state. And that's essentially all the observer is doing, is just performing an action when notify is called. Command pattern will come in, we'll show off a command. So command pattern, we have the timer event manager. What we can do is basically make a command that wraps a set of functions up. We can send it to the timer event manager and say, execute. All the commands will have this execute method. And, say in 5 seconds, I want you to execute this. So timer event manager will execute this. And what this one does is animation sound. So it'll play the sound, do a bunch of stuff to get whatever time it needs to add itself right back on, and we can just reuse this command. We can throw it away. We can do a whole bunch of stuff. It's actually a very versatile pattern. And I don't know if the UML is really that descriptive. No, this just shows that we have a timer event that is linked to a command, and it has this execute. Not a whole lot to see. Composites, another eyesore. What we really need to focus on is that there's a component, and that is the base class of a leaf and a composite node. So a leaf node, an example of those is like end of the line. There's no children under, an alien or a missile. That's the end. There's nothing under there. They don't contain any further ones. Whereas for the aliens, for example, they're all in a group. So the grid, the alien column, those are example of composites. And that basically says there's more under me. I contain things. So go and, look until you hit leaves, basically. And this way we can construct a tree of pretty much any shape we can imagine, as long as there's one root node to start from. We can have, 100 composites on it, each with 3 leaves if we wanted to, or where every one has a different number of leaves. It's pretty versatile there. This stuff, not super important, just iterators and whatnot. And finally, well, actually, there's 2 more, I guess, but object pooling. So back to our texture manager, it's just a good one to show off. A lot of our managers are using object pooling, pretty much everyone. They'll have an active and a reserve list. And what happens basically is our active list starts at 0 nodes because nothing's active. We load up our reserve list with however many we think we'll need. And when we actually need a node, instead of calling new, we just grab one off of the reserve list since we already called new on it when we loaded the pool up. And we use those first. And then when we run out of nodes in the reserve, we create a whole nother batch so that we don't have to continuously call new. And that when we do end up calling new, we just call it a bunch of times at once instead of spreading that out and just kind of, context switching a lot. So that'll happen there. And finally, template. This UML is basically just showing that the image manager's base class is using this derived create node. It's just an abstract method, so the derived class has to implement it. And what this does is when the man base is creating new nodes to put on its reserve list, it doesn't know what type of nodes those need to be. or when it's adding a node to the active list, it has no idea what it needs to be. So it calls to the derive class to actually make the node and hand it back to it, because the manager base only knows the node bases. It doesn't know what an image is, but the image manager does. And I think that is it. I do not have two-player implemented, so it's single player only right now. And my UFO doesn't drop a bomb. I didn't see any videos or anywhere that that actually happens. And so I decided not to implement that. And the only other thing I didn't implement is the bomb versus missile is not showing a splat currently. And I just sort of ran out of time to do that. So, thank you.